This is a series I'm putting out there with my broken down explanations for the formulas relevant to me currently. Each video is going to feature a simplified explanation for each formula. I hope that these videos will help to reinforce the material you already know, remind you of the material you may have forgotten, or even help you to prepare for that test you're cramming for. I plan on posting a variety of videos other than just math and physics help, so please do subscribe and keep an eye out for some of my other stuff, especially if you are in engineering or looking to get started in a similar major. Thank you for watching. I am going to be talking about work in this video. We will be going over every single thing here, but right now we are just going to be talking about the work of a variable force. I'm going to break it down as much as I possibly can. Hopefully you understand and can follow. So this is the work of a variable force. Here's the equation. I might go back to it to refer to it later. We will see this along the way. I'm going to explain each part, why things are the way they are. You should be able to follow along with this with, I don't want to say minimal math experience, but this should fill in some of the gaps and it should remind you of anything you've forgotten. This term here, variable force, this means a function of something. See f of x, this is just a little example, just to represent that. But you can see right here, imagine that this f of x was a force. It could have been a force value, negative x squared minus 2x plus 3. I have not yet gotten a force like that in an exam or a quiz or anything like that, but that is an example of what a variable force could look like. More reasonably and more basically, right? I think a variable force would look like this. So you see F is equal to 16s, S being a position, right? That's a position variable. And I know there are other letters that they use instead of S for position. S is the one that I am most familiar with. Now, F equals 16 newtons. This would be an example of just a value. It's not a function of anything. The force is 16 newtons. So that's more of a basic physics problem, and I will explain some bits of that. I'll make a couple of tie-ins. So the work is equal to the force times the distance, right? This is the very most basic formula for work. It's different from this, but this is very basic. We use this in the scenario where we do not have a function as our work value, or not work value, force. Our force isn't a function of something. Our force is just a number. That's when we use this, right? So we're including cosine, which you could see here, cosine of theta of ds, right? Work equals force times distance. D of cosine of theta of x could also be written as d cosine theta of d. I've seen it written as both. More commonly, I use the second option. And then this would give us our final, most basic formula for work, being W is equal to F times cosine of theta of D, or U is F times cosine of theta of D. It depends on if you use W or U for work. Now I will explain why theta is relevant. So, yeah, why cosine? So our F is our force, and this right here, this is a diagram. I just found this on the internet. This is probably something you'd see in a basic physics course, or maybe statics. You could definitely see something like this. So the force applied is going along the hypotenuse, right? You can see that F is the force, and the displacement is in the x direction. So you can see right here how I have cosine of theta of x, right? This is the displacement. We have our x as well as theta. Theta is the angle between the displacement and the force applied, which is written right here. So we use our theta value, which is the angle between both of those, and you multiply that, or you have the cosine of that angle. And if you remember SOHCAHTOA, some old hippie caught another hippie tripping on acid, you will figure out that it is cosine which you are supposed to use for this. So now I'm going to explain why this is relevant. So I just explained the most basic part of this, and hopefully that makes sense to you. But now Where is S coming from? What is U1-2? What is all of this? So U1-2, this is talking about U, or work, from point 1 to 2. So this is dependent on two positions, right? The work of a variable force depends on position. And part of the way that you can tell that is because the ds being here. It's not what ds means, but think about it as like dependent on s, dependent on position. That's one explanation I always found helpful. If it was dt, it would be more dependent on time. That is not what the d means, but you can pretend that that's what it means. So you have the integral between S1 or S2 and S1, S1, S2, right? These are the positions, position 1 and position 2. And as I said, S is our position variable, right? Now, if you remember from calculus what we're using an integral for, I remember when I took calculus, I didn't get it. It took me a very long time. It actually took me using it practically to understand it. I didn't understand it until I was taking physics and using calculus and physics. But when you have an integral, generally speaking, I mean, that's what these 2 points are for. It's representing a value, something between here and here, right? That's the simplest way of looking at it, I would think. In this, that's definitely what it's looking for. We know that u between 1 and 2, this is telling us that our work between 1 and 2, 2 different points, is equal to, these are the 2 different points that it's referring to in 1 and 2. And this is our f. Cosine theta ds. So ds, because that's the distance. Cosine of theta, well, that's this distance. Cosine of theta, because it's here, that makes up this greater distance. If you want to look at ds as x instead, maybe you can replace it with dx, and as long as these are x2, it would functionally be identical. Some people give it different things. It was always very confusing to me. I think x makes more sense. I think that's easier to understand. But yes, if you think about them as your displacement variables, which they are, displacement x, dx, x1, x2, then when you do see cosine of x, whatever, this is your distance, right? That's your not distance, that's your displacement. That's your d from here. Your f, that's your force. It doesn't change. It's still force times distance, right? And this is your work. By having this ds at the end, I mean, as I said, all you're doing with this integral is saying, I want to find this between these 2 points. And since these hold the points that you're looking for, this has to go along with it, basically, and that gets changed. That's not a scientific way of explaining it. That's the simplified, low calculus way of understanding it. I would think that would be a pretty good explanation for not really like relying on calculus to explain it. But yes, hopefully my explanation made sense. I know I broke up a bit during this video, so I'm going to try to be more congruent for the next couple. But yeah, I'm making a couple more videos just like this. Going to explain all of these. Going to explain more, no doubt. If you thought it was helpful, I'm going to have very simplified explanations for everything I do. But yeah, all right. Thank you guys for watching. Hopefully you got something out of it.